the slope of a linear graph, and we need to talk about the definition of what a slope actually is. And the slope is just a numerical value for the slant of a line, or the tilt of a line. So it just tells us how steep or how shallow a line is going to be on the graph. Okay, there are 4 different types of slope, and we're going to go through each type. So I'm going to draw a line up here for us to look at. So looking at this line, I always think about a person walking along the line. And I have my person always walking from left to right. And the way to remember that is when we're reading sentences, things like that, we always start at the left and read to the right. The same thing applies for graphs. You always read a graph from left to right. So if my person starts on the left-hand side of this graph, he would be walking up this line, which means he would be going uphill. Okay? An uphill slope is a positive or increasing slope. Okay? But it means that we're going to have positive numbers that are going to represent our slope, the slant. Okay? Our next type of slope looks something like this. Again, we're reading this graph from left to right. All graphs are read from left to right. So if I put my person on the furthest left point of this line, as he's walking along this line, he would be going downhill. Okay, so this is a downhill slope. Right, and it's a negative slope or a decreasing slope. We're going to have negative numbers represent a slope that's going downhill. Okay. Now, those are the most common. Positive and negative are going to be our most common slopes, and those are going to be the ones that we have to count out and actually find numbers for. There are 2 others that are exceptions to those rules, and they look a little bit different. And the first one looks like this. Again, we put our person on the furthest left point of this line, and he would be walking across. Looking at this, our person's not going uphill, he's not going downhill, it's actually staying constant, okay? It's as if he was walking across a floor of a building, okay? There's no change in the slope. This is called the zero slope, 0. I always write the word 0 after it, especially when I'm taking notes and things like that, to help me remember that that's a 0, not an O. So that's the 0 slope. There's no change. And if you think about it, 0 makes sense for this slope because it's neither a positive number nor a negative number. Okay? 0 isn't positive or negative, it's just constant, straight across. Okay, so no uphill, no downhill, straight. And then last, we have a line going straight up and down. Okay? Now, the difficulty with this one is finding the furthest left point of the line. Because the line is going straight up and down, it's all the furthest left, so we don't really know where to start. And we don't know where to put our person either. The problem with this is that it's a lot like a wall. If somebody tried to walk along this, they would just fall off. Okay? They wouldn't make it. There's no way to walk along this line. We can't actually walk up a wall. So, we have a special name for this, okay? So the one that's like a wall that we can't walk on. It's called undefined. Okay? Now, looking at the word undefined, we see the word define in here, which is like definition, okay? Undefined means there's no definition, no way to actually write this in numbers. So we actually write this word. There's nothing else to it. You write undefined. Okay? You can't write it in numbers. It's not uphill, downhill. It's not positive, negative. It's not 0. It's undefined. So anytime you have a slope like this would be your answer, undefined. Okay? You just think about that as the wall. You can't actually walk on it, it's impossible. So that's our answer, undefined. No numerical definition. Okay? So what we're going to be doing next is actually calculating some slope. And remember, we're only actually counting out uphill and downhill slopes. Zero slopes and undefined slopes, you can just tell by the picture. You don't actually have to count it out. So for positive and negative slopes, we're going to count this as the rise over the run. It's going to be a fraction. All right, there's going to be two directions that you have to go. The rise is going to tell us how many to go up or down for the line. And the run is going to be how many spaces we have to move, left or right. So we're going to take a look at problem number 1. Our first point is here, and our second point is right here. We are going to actually calculate the slope between these 2 points using the rise over run method, okay? Counting up or down and left or right between points. Now, it doesn't make sense for you to tell me I'm going to go diagonally about 1, 2, 3 spaces, right? Because I have no idea how far diagonally I'm supposed to go. If I decide, okay, well, diagonal to me is about 1, 2, 3, so your point should be right about there, I'm in a totally different place, okay? So make sure that you don't just say, go diagonal, and you're going to get there. The way that I think about it is city blocks, okay? If you were trying to tell someone, like in New York, how to get from one building to another, you wouldn't tell them to go through the blocks because there's buildings there, and they wouldn't actually be able to find their place, right? You can't just walk through random buildings. So you would tell them, oh, okay, well, you're going to go north 3 blocks, and then turn right, go 2 more blocks, and the building will be on the left-hand side, something like that. And that's what slope, this fraction, helps us with, okay? It tells us the way that we're supposed to go, like city blocks would. So the first thing I'm going to do is calculate how many up or down I need to go. And I always start at the furthest left point because that's easiest for me to work with. So I start here. To get to my next point, I would have to travel up, okay? And then from there, I would have to travel over over to the right 2 places. So when I count this, I start here and I go 1, 2, 3. Do not count where you start from, okay? Wherever you start, you're not going to say, okay, well, walk a block to get to where you're starting. No, you start here and you walk 1, 2, 3 blocks up. So it would be 3, and then starting from the place that you left off, count over 1, 2 places to the right. So 2 would go at the bottom. Now you need to make sure you know if this is a positive, negative, 0, or undefined slope. So if I have my person walking along this line, he would be going uphill, so this is a positive slope, a positive 3 over 2. You don't technically need the positive sign, but I just want to talk about it and make sure that you remember why it's positive, because we're going uphill. Now, when you're dealing with slope, please, please, please do not make this a mixed number. I can't stress that enough. 1 and 1/2 does not make sense for slope, okay? Because now you've changed this from being the up or down number and the left to right to a whole number, and that doesn't make sense when you're talking about directions, okay? Taking an improper fraction for slope and making it a mixed number completely jumbles up your directions. I don't know what's going on when you say 1 and 1/2. I don't know what a whole number means. You cannot combine an up and down amount with a left or right amount when we're talking about slope. So leave them as improper fractions. Saves you a little extra time. You don't have to change it into a mixed number, okay? So positive 3.5 would be our slope for number 1. All right, let's take a look at number 2. We have our first point would be here, and our second point is here. do this time is take a look. Is this an uphill, downhill, zero, or undefined slope? And when I draw my person along this line, I can actually draw him on there, so it's definitely not undefined. He would be going uphill now. It's a very steep uphill, but it's still going uphill. So this is a positive slope. So I'm going to put my positive sign just so I don't forget. From there, we need to figure out our directions between our 2 points. Starting at the furthest left point, I would go up and then to the right. So if I count this, I would go up 1, 2, 3, 4 places. So 4 would go at the top, and then I would go to the right 1 place. So my slope would be positive 4 over 1. Now, this is an improper fraction that can be simplified to just positive 4. Now, the reason why you can change this to a whole number is because, remember, all whole numbers have a denominator of 1. So if you just write a whole number, it's assumed that that denominator is 1, which it is. Okay, so you don't have to write that. And on any test or anything like that, if they're asking for a slope, they're not going to put the denominator of 1. They'll just put the whole answer, okay, the whole number answer, which is 4. So 4 would be my solution for number 2. One thing I want to point out, please make sure you are counting the up or down amount first and then the left or right. Most people, whatever number they count first, that's what they're going to put in the numerator. All right, so if you count the left or right number first, it's very likely that you'll put the 1 and then the 4 underneath it, and that's the wrong answer, okay? 1/4 is very different from 4 over 1. So please don't do that. Make sure that you count the up or down amount first and then count left to right. All right, number 3. Okay, our first point is here, and our second point is here. So, first thing I want to do is put my person along this line. Okay, so if he was walking, start at the furthest left point, he would be going downhill. Alright, so downhill means negative slope. So this is going to be negative, and then I have to count. Starting at my furthest left point, remember, go up or down first, because that's what you just naturally want to put at the top. So we're going to go down this time, and then to the right. So I count down 1, 2 places, and then I count over to the right, 1, 2, 3, 4. So my slope is negative 2/4. Now, if you can simplify your fraction, please simplify, okay? You don't have to make them into mixed numbers. Please don't do that. You're not supposed to. But you do need to simplify. So 2 and 4 are both divisible by 2. So my answer is going to be negative. I already know my slope is negative. 2 divided by 2 is 1. 4 divided by 2 is 2. So negative 1/2 would be my answer for number 3. Okay, number 4. Our first point is here. The second point is here. Now, first thing I want to do is figure out if this is positive, negative, 0, or undefined. Looking at this, I'm trying to figure out where to draw my person to figure out if it's going uphill or downhill. But it's going straight up and down. So remember, we talked about when it's a wall, our person can't actually walk on this wall, okay? It's impossible. You can't do it. All right, so you fall off. So this is a special one. It's not positive. It's not negative, okay? Remember, if you can't even walk on it, that has a special name, and it's called undefined. That is the slope for number 4, okay? There's no way to define it with numbers. This is what you write. That's it. It's just undefined. There's no number that you can do. Don't try to count between the points. It's undefined. Finished. No counting needed for this one. All right, let's take a look at number 5. number 5, our first point is here, and our second point is here. So the first thing we need to do, is it positive, negative, 0, or undefined? Well, there is some slant to it, so it's either going to be positive or negative. If I put my person at the furthest left that I can go on this line, it would be here. That's the furthest left place. So he is going drastically downhill. It's steep, but it's not undefined. You can still walk on it. It's just going downhill very quickly. So this is a negative slope because it's going downhill. Then remember, we need to count the up or down amount first and then left or right. So I always start at my furthest left point. I'm going to go down and then to the right. So I count down 1, 2, 3, 4, 5 places. So this would be 5, and I have to go to the right 1 place. So I'm negative 5 over 1, and remember, if you can simplify, please simplify. So 5 divided by 1 is just 5, and I know it has to be negative because it's going downhill. So negative 5 is my slope. Okay, let's take a look at one more together. Then you can do the last 2 on your own. For number 6, our first point is here, and our second point is here. Draw our line. So first I need to figure out if this is positive, negative, 0, or undefined. So I'm going to draw my person at the furthest left point of this graph. So it's right here. This is as far left as I can go. So if he was walking along this line, it's not going uphill, it's not going downhill. So neither one of these. Alright? But he can still walk on it. So it's like the floor. So if you can still walk on it, this is a constant slope, which is the 0 slope. Remember, 0, not O. So this is my 0 slope. All you need is the 0. Okay? And that is your slope. There's no counting that you need to do. And that's our answer for number 6. At this point, go ahead and pause the video, do problems 7 and 8, and then come back to check your answers. Okay, for problem number 7, you should have noticed that our person would be walking uphill, so it is a positive slope. And then remember, you must count the up or down motion first and then left to right. So he would be going up 7 to the right 3, so it's 7 over 3. And then for number 8, our person would be walking downhill, so that's why it's a negative slope. Our up or down amount is 2, and the left to right amount is 5, so it would be negative 2/5. And this is the end of our lesson on finding slope from a graph.